So this week we're going to be looking at colligative properties. Remember that colligative properties are there's a list of them, and you can go through them in the other video, and they are the properties of the solvent that change as the solute is added. So this week we're going to go to this website right here. This is also linked right on Schoology, so you're going to want to go to this website, which is the Gizmos website that we've used before. And so as you're doing that today, so this week you're going to experiment with colligative properties. Now remember that colligative properties are properties of a solvent that change as solute is added. So we're going to use the Gizmos site again to experiment with that. And the Gizmos that we're going to use today has already been assigned to your class, so you may need to review your username and password. So please send me an email if you need that and you're not able to sign into that. Here are your class codes in case you need your class code again. So you may want to take a picture of that. Be aware that it is also case sensitive. So you'll need to make sure that you have that on as well. All right, so once you're at the website, you're going to see something that looks like this. Now, we're not going to be looking at this little side arm thing with the blue liquid in it, and that because that has to do with as water evaporates, it's going to travel in there, and it's going to affect what we call vapor pressure, which is one of the colligative properties. But you're going to want to look at the molecular view, and this is what it's going to look like. And so first you're going to experiment with water. Now you need to be aware that one of the things that you're going to change here is the air temperature. And so as you change the air temperature, you're going to have to wait just a minute or two for the water temperature to get to the same temperature as the air. You can always press record to see what the water temperature is. And so as we're doing that, the first thing you're going to do is investigate the different temperatures for water. What temperature does water freeze at? What temperature does water boil? The lowest temperature that you can get the water to boil. And then click record. And you'll see these different air temperatures. Your solute concentration here is going to say 1. It's really 0. We're going to add no solute. You're going to want to then record your data either on your own piece of paper or take a picture of the screen. Then what you're going to do is you're going to add the solutes. The first solute that we're going to add, of course, is C12H22O11. That's that sugar, sucrose, that you put in your coffee or on your cereal in the morning. And you'll remember that sucrose is a covalent bond. It's all nonmetal, so there's only going to be one particle in this solution. And that's going to be an important thing for you to record on your data. As you're doing that, you're going to, again, change the temperature. Find the freezing point. When does it freeze? Find the what's the lowest temperature that it freezes when the liquid turns to a solid, and then find the boiling point. What temperature does the liquid turn to a gas? Now, at any given point in time, there's only going to be 3 vapor molecules above the water, because remember, those vapor particles are going to go up in this side-armed tube. After you test sucrose and get some information about sucrose, you're going to check sodium chloride, again making sure you know the number of particles, calcium chloride, and then potassium chloride. So you're going to test all of those solutes today. Again, of course, note the number of particles that are formed each time when you add one of those solutes. Again, like I said, you're going to do calcium chloride, you're going to do potassium chloride. I've also given you the formulas for those there. Once you're finished with that, studying the different solutes that you're adding to the solution and see how it affects the freezing point and the boiling point. You're going to then select one solute and use the slider bar for concentration or solute concentration. So you're going to need to click study concentration at the top and then change the concentration of your solute and see how that affects both the freezing point and the boiling point. Here's a sample data table that I made for you to use. You might need multiple ones of these or add some more rows down here. This is all that will fit on this screen, and we're going to begin looking at our solute concentration, the number of our solute particles, the air temperature, waiting just a couple of minutes to observe the solution after changing the air temperature, and then what state it is in. After a couple of moments, the air temperature and the solution temperature will be the same.